Hello, my name is Savio and this is another OpenSwoole video. Today we'll talk about routing socket messages. Let's see. In this video we'll go over the topic routing socket messages. For this topic we divided the video in a few sections. The first section is dependencies, the second section is socket conveyor, app frontend, app backend, and customizations. So, here we are. As said in this video, we will build a router for a WebSocket server. This router will direct our messages sent back and forth to have specific handlers for those. To do it, we have many different paths. I built it a while ago and have been maintaining. I'm talking about a package with some implementations that I thought could help projects to have sockets set up faster. The name of the package is Socket Conveyor. You can install it via Composer. Here's how it goes. So go there, Composer, acquire, PHP, Socket Conveyor. And that's it. Because now we are building a more complex application, I'll move some components to other directories and use namespaces to reference them there. We will add some configurations for autoloading with Composer, so to do that, you add your Composer file like this. Composer JSON, oops, I added something here. Let's do here autoload. Autoload PSR4. I always forget this for some reason, and it will be my app, and that my app will reference to source directory. And with this in hand, our application will every time we use the namespace my app, it will try to find this file inside the source directory. All done with the backend dependencies, let's install some dependencies for our frontend. Because we are building something more complex than the previous example, we might need to consider ways to simplify so we can move forward without too much difficulty maintaining. I use Laravel Mix commonly due to the simplicity of working with it. Of course, you probably use what is better for you and your team. To install it, we'll run npm install Laravel Mix. And that will install the package, and we still have things to be done. That will require us to place the webpack file, and we'll do right after this here. Okay, all done. I have some content prepared for us. Let's just go there and webpack mix.js and paste it here. What it's saying is let's require Laravel Mix, and Mix will get everything that is inside resource/js/app.js and create a bundle, like minify, process this JavaScript as a file with the same name in this directory. That's it. After that, we install the Socket Conveyor client package. This package will make it easier for us to communicate with the server, as this package wraps some of its rules and complexities. Let's do it. npm install socket conveyor client, and that will install the package for us. With these dependencies installed, we can jump into the implementation. Now, talking about the implementation, we will review the package installed called Socket Conveyor. Here is the website of Socket Conveyor. If you want to know more about it, please go to the documentation shown in the video or presented in the description. It is a package that delegates handlers to specific socket message patterns. The functionality we can see here in the outline. The functionality we will need from Socket Conveyor in this video are listeners, which is right here, case 3, and channels, which is the case 2. The functionality of listening actions found right here is a filter that specifies which actions from the server a given client wants to receive. Notice that in this image here, the messages are broadcasted according to their respective listeners. Now, the functionality of channels is what it says. Let's go there. It creates channels through which clients will communicate. Notice that the message sent to the channel are received by all clients connected to the same channel. For those two functionalities, we will need to also implement persistence interfaces to power them. This is how the package knows which users are connected to which channel. Also, how it knows which client is listening to which action. At the channel functionality, as you can see in the example, let's go to the example right here and right here. There is an out-of-the-box class for you to use, and we are going to use it. It's called Socket Channel Persistence Table. This class will use Swoole channel to persist its data. And there is a similar package, a class, let's go there. But this time, like each class here implements its own context data, so they are structurally different and they have different methods. In the case of the listening actions, let's go there. It's called Socket Listener Persistence Table, and it also uses Swoole channel to persist that information. We need to recreate a router for every incoming or outgoing message for two reasons. Instances within the event callback are resilient, so it is good practice to avoid the usage of resilient instances that carry sensitive data. The other reason is that our router and actions deal with connections references. That said, they will leak data if you reuse instances throughout requests. So to avoid all of that, let's always recreate the router for every incoming message. Now, let's see how to prepare that on our code. To keep it organized, I'll add some comments separating the sections. First, we create a persistent instances. So let's go there and add some right here. I already have it prepared. Let's give some space. Here they are. Let's invoke them. Right, that's it. Notice that the parameter on the router also accepts arrays, so that's why we are preparing an array and not one variable per instance. Second, I will add a section for the helpers. By the way, this section will be helpful for future helpers that need to exist in this file. Or for us to quickly identify them here, and then we can move them to another place at once, because they are already isolated in a section, right? So I already have some code prepared for us. Here it is. All right. Why I'm creating the router in a helper? I'm creating the router here because we will need, as you'll see further in the video, to send messages on other server events than the message event. So by having this in a separate function will help us to be able to do that. And now, just the missing piece here, just invoke the things we don't have. In this case here, we have 4 actions that we will create ourselves. So let's go there and make our custom actions. The first one is the welcome action. this one right here. So let's go there and create this action. I already have it prepared, so let's put it in the right place. First, we go here. We don't have the source directory yet, so let's go there and create it. Source, and then inside of it, let's create actions. And inside actions, I'm going to paste my welcome action. And let's see what it does. This action will be sent to the client when the client connects. It will be helpful for us to send to the recent joined clients the list of other connections already present in the server. So this is exactly what you see here. A message, whatever message is coming, and the list of connections. The second action, let's go back there, is the secondary broadcast action. So let's go there and create, and add the secondary broadcast action. This action will be used to only to separate a broadcast from the one already present in the package. The package already comes with the broadcast action. This will be useful so we can see when we listen to one of them. So for example, we broadcast through the primary broadcast, which is the one that comes already with the package. And if we listen to that one, we won't receive messages from the second one. Going back to see the ones we still have to create, we have the new connection action and the closed connection action. So they are complementary in the sense that they serve to inform clients of new and closed connections. That's all. So let's go there and create them. First, the new, and then the closed. And let's visit its code. It's very simple. When there's a new, the server will send this message to all clients that wants to hear about it. And the same thing for the closed. Now we go back there. Let's close everything. We go back here and import these classes. Now we will send some information to clients at the open event. This event happens whenever there is a new connection. So we will send a welcome action where we send the list of existing connections. So remember that we are sending all the connections available at the welcome message. So if we go there one more time, just remember, here we have a list of connections. Notice that this is a channel persistence. If you want to know more about this implementation, you can just go there and see how it's done. So this is the interface. You can override it, implementing your own persistence. But yeah, this is how it's working here. And so we will send the existing connections to the new connection. So the customer is aware, for example, there are 3 users already connected. When you connect, you will receive a message, the welcome message, saying there are these 3 connections with their respective FDs. And here is, we don't have the open event implemented here. Let's go ahead and add it right here. So as you can see, I'm adding the persistence variable from the global scope inside this callback, and then I dispatch 2 messages. The welcome message, as I said, and then the new connection, as I said. Now going to the message event, we'll send whenever action is coming. according to the action, of course. So let's go there and do it. Let's get rid of all of this as well and add just the process message function. And again, we need this from the global scope, the persistencies. And now we need to implement to send another message at the close event, which is going to be the close connection action. So let's go there. We don't have the close event implemented. We're going to implement it ourselves. There it is. So as said, the close event is going to send the close connection action to all the remaining connections. After all of that, the missing piece here is just the template. That will change and also will affect our server's configuration. Continue from what we built in the WebSocket part 1, the new template will have some differences. They are added for two reasons: least connections present in the channel and properly routing messages coming in. Because we have some external JavaScripts now, we'll add some static handlers configuration to our server so the server serves those files. This is already known if you've been following our previous videos. I did the same strategy for our HTTP servers there. You can find more information as well on the OpenSwoole documentation. The link will be in the description. So that part is basically this right here. So what we're saying is that document root is going to be public. So whenever there is an asset loaded like that, it's going to be loaded from the root, and the JavaScript directory, the JS directory, is going to be the one served that way from there. Now let's talk about the front end. So let's go there, open the views home file. This is the template the way it is right now. In this new implementation, we are going to do something similar, but we'll change it in order for us to have more. So the template will change, in other words. Because it's just HTML, we won't go over it in too much details. I'll focus on JavaScript. We will create a separate JS file that will run the initialization procedure just like it is running right here. And it will initialize all the event listeners needed to our client to function correctly. And in this new implementation, we'll have the Socket Conveyor client package handling a lot of the complexities here. So here, I can simply override with the new home.php file. And as you can see, it's the same layout. A few things changed here. Now we have connections list with an ID and the output, and then we have also the same form. But here it's different because now we have a separate JavaScript file, and after that we have, and after the page loads, a function initializing the app, passing all the DOM elements references that we have that will respond to events. Let's put like that. And here is the server configuration. As said before, the app.js file will be bundled with all the other JS files in this app. Right now we have two. We didn't create those yet. We're going to create the first one. This process is specified in our webpack file. So just to put in context, in this webpack file, we specify that the assets in the resource.js are going to be bundled in the public/js file directory. So that's it. Let's go there and create the resources directory. And then the app.js file. And now we bring the content, and I'll explain. Let's just show the outline. So the most essential part of this app.js file is the WS router. So let's go there. This init is the method called at the home.php file, and the WS router is called right here, and this will bridge what we want to do on our app and the WebSocket server. We give it two callbacks right here for events from Socket Conveyor's client, and the other callbacks are all routes. So these events here, if we don't pass them, there will be no loss. The only detail here is that we won't show when a connection is finally established or closed. So let's go there. You can see it right there. We're just displaying messages. We could do something else too. This is when after the connection is actually established, and this is handled, by the way, by Socket Conveyor client that I'm using here in this example. And all these other callbacks, they are for the actual actions. This is the router that we have been talking about. Every time these actions happen, we'll have handlers for them. The handlers are basically displaying connections separated by comma or showing incoming messages from the channel. Let's go there and see. Welcome action, for example. This is when we receive the list of pre-existing connections, right? So if we go there, you'll see that we are relying on the message. The incoming message is a JSON, and we put the current connection ID in the list, and then we loop through the connections in the message and add each one of those in our app.const property, which is our list of connections, and then we add those to the connections list box element in our HTML. Basically that. So each handler here will be doing something similar for us to have the real-time experience. Let's go there and implement that router. Let's bring what I have here for you, and there it is. This is all the router is, and it happens because we are using the Conveyor package. The Conveyor package is basically creating the WebSocket, the vanilla.js WebSocket client, is connecting to Socket Conveyor, like to the WebSocket server, and it's doing the procedures it wants to do. So, just to put us in the context, let's see the implementation. So let's go back to the home. We're sending the port 8585, which is the port of the server. And then we are sending the channel. These are the configurations we are sending to the Conveyor client. Why we're sending a channel? We are not connecting to the channel here, and we are not sending a message here saying connect to the channel. And if you go on the Socket Conveyor documentation, the connection to a channel happens through a message. So you have to send a message saying connect me to that channel, and then the server says okay, you're connected to the channel. That's it. We are not sending that, and I explain. It's all happening right here. The Conveyor has some options. So if we go there, you'll see that these are the options. So you can specify the protocol, you can specify URI, port, query, the query like in the URL, the channel, listen. This is like to listen to specific actions, you know. And then you specify like the callbacks, and if this is like forever reconnecting. So there's a difference here with the WS Reconnect and the WebSocket. WebSocket is the vanilla JS that once the connection falls, that's it. And if you want this connection to be resilient, you better use this one. So whenever the connection ends, like the server restarts, as soon as it's come back online, it connects automatically. So it's an option, right? I put it off, like off false, because this might not be what you want in the development environment. So you can always configure this to true. And then the reconnect delay for that specific package. So that's it. So we send the options, and the conveyor, because we're sending the channel, conveyor will automatically, as soon as it connects, it will connect to the channel we want. We don't have to care about that right here. What we have to care about is the options we send through. To make it more dynamic, it's a little complex, but this is the price we are paying here. We are paying the price by adding extra configuration to avoid having to deal with all that complexity, like to the callbacks, the possible race conditions, all of that. That's the trade-off here. So the router magic happens actually right here. This is the router message. This here is just the bridge between what we want, which is this binding here, and how the web server interacts with the client. That's all. So with this in place, we'll be able to see our application routing properly the messages. So now, back to our terminal, what we're going to do is we're going to run an npm install, just make sure that everything is in place. And then we're going to run an npx mix build, which is the Laravel mix package that I installed to facilitate my JavaScript bundling. Let's build our assets. There it is. We have now the app.js in the public directory. Okay. And now there it is. So here we are. Let's see if it works. I'll access the server on this Windows here, and we should see the list of connections that are starting all in real time, and then the message is being broadcasted. Let's see. Connection number 1, number 3 in this case, 4, 5, number 6. So all those 4 windows are connected to the same channel, and they can see each other in this list. If I refresh one of those, it should update the ID in the other. So for example, let's update the 3, which was the first one. Let's refresh this. This should put a connection 7 on all of those. It worked. So connection 3 doesn't exist anymore because it's connected when I refreshed, and connect again. The same thing happens here. The same thing happens here. The same thing happens here. So it's working. Messages, let's see them. Message 1. Everybody receives but the first one. Message 2. The same happens. Message 3. The same happens. Message 4. The same happens. It works. So one might ask, what if I want to receive the message I'm sending that is not implemented in the given actions, the out-of-the-box actions that are coming with the package? But let me show you one thing. Our actions extend some existing actions from Socket Conveyor, as you can see here. That means that we are using a lot of X functionality, which is why our code ends up being so small. Notice that we are extending those classes. So here we are just reusing the broadcast action functionality. we still have some room for customization because of that. Notice that we are not overriding any of those methods that broadcast action and eventually the other abstract action behind broadcast is doing. Just for the taste of what is possible, let's also send the message broadcast to the client who sent it. Because as you notice, the message, when you broadcast a message, the message broadcast only goes to the other clients, not to the client who sent it. Let's customize it to send to also to the client who sent it. To do that, we just have to override the method that takes the decision and change the conditions. At the moment of this video, this could be found here. Let's go there, broadcast action, and then we have some rules here. For this specific decision, we are going to the method who decides who we are broadcasting to. So let's go there. We have the send method, and the send method goes through a few rules, but where we actually decide is broadcast to channel. Let's go there and see the conditions. And I already know, of course, I wrote it, but it's right here. We are skipping from pushing to the server when we find that the user who sent it is actually the current user in this loop. So let's override this method on our own action and comment this out. That's all we need to do. And then we go on our app.js file, and we are not routing anything to that secondary broadcast action. Let's go there and implement our own. And let's just use the same handler, which is to display the message in the UI. And also, when we submit a message, we are going to send, instead of the simple broadcast, we're going to send a secondary broadcast, which is the one we just customized. And then I'm going to bundle again, like to build and running the Laravel mix bundle command, and then we'll see in the UI. Let's go there. First, we have to recompile, rebundle, whatever. Mix build. There it is. And now we run the server again. And now going back to our browsers, let's connect everybody again. And let's see if the message is also coming to the origin. It is. Everybody now is receiving. So yeah, this is how you also customize the functionality here. In this video, we saw dependencies, socket conveyor, app frontend, app backend, and customizations. All of that to cover the topic of routing socket messages. In our next video, we will see about building a backend client for a WebSocket server. See you there.